Good morning, guys. This is P.3. We're going to start talking about polynomials and special products. I understand we're having some Zoom issues at school. Some teachers can get on, I cannot. So I'm going to teach this lesson this way, and then tomorrow in class I will go over any of the homework questions that you have from Friday night's homework and from the stuff for tonight. So just do the best you can, follow along with the video, pay attention, write down questions that you have, and then we'll go through it together. So when we talk about polynomials, poly means many. So we have things called monomials, which means one term. I'll write this down for you. A monomial is one term. We have a binomial, which is two terms. We have a trinomial, which is three terms. And then we talk about polynomials. Terms, guys, are separated by plus and minus signs. So if we look here, there's a minus sign here, a minus sign here, a plus sign here. So in this case, we have 1, 2, 3, 4 terms. When you write a polynomial, you always want to write it in standard form. Standard form just means the exponents go from biggest to smallest. They go in decreasing order. So in this case, look, you have 7, then squared, then 1, and then 0. This is x to the 0, which would give you 1. The degree would be the biggest exponent that you see. So the biggest exponent that you see is 7. And the leading coefficient is the number that's in front of the letter that has the biggest exponent. So it's important for you guys to understand that the sign in front of the term stays with it. So like in this case, this says 4 minus 9x squared. Well, the 4 is positive and the 9x squared is negative because this sign goes with it. There are two terms, so this would be called a binomial. And if you're going to write it in standard form, you have an x squared and then you have an x to the 0. So x squared would be the biggest exponent, so you would write it in descending order from negative 9x squared to positive 4. Your degree is 2 because that's the biggest exponent you see, and then negative 9 is our leading coefficient, so number in front. In letter C, you have, this is a constant. 8, which is just a plain old number, is the same as 8x to the 0 power, because remember, anything to the 0 power is 1. So in this case, you'd write it in standard form. You just write the number itself. The degree would be 8 and the leading coefficient. The degree would be 0 and the leading coefficient would be 8. All right, so if you have a polynomial that has a variety or a combination of variables, do you see here how we have x's and y's? Here are x and y, x and y. You have to sum the exponents in order to get the degree of this polynomial. Sum means to add. So in this case, you're going to look and say, okay, well, this sum would be 9 because 3 plus 6 is 9. This sum would be 2 because x to the first, y to the first. And this sum would be 11. So 11 would be the degree because that is the greatest sum of the exponents. The leading coefficient is always of the highest degree, so your leading coefficient would be negative 1 here. And if you didn't have a variable or something, that's totally different. We'll talk about that later. All right, so now if I look and I'm asked, are the following going to be polynomials? Well, there's different things that make a polynomial not a polynomial. That would be fractional exponents, or if you have a denominator of a negative exponent, or if you have a variable in the denominator. So if you have fractional exponents or negative exponents, then that would not be categorized as a polynomial. We're going to talk now about adding and subtracting, multiplying and dividing. We always write, like I said, in standard form. We'll talk about that in a second as we go through here. But when you are combining, first thing you need to do is look, there is a plus sign in the middle here. All that means is we are adding like terms. So I have a 5x cubed here and a 1x cubed here. Well, 5 plus 1 is 6. So when I combine these, I would have 6x cubed. Now I look for some more like terms. I have a negative 7x squared. Remember that negative sign goes with the term. and I have a positive 2x squared, so negative 7 plus 2 is going to give me a negative 5x squared. And then I'm going to say, okay, I have x cubed, x squared, now I have x to the first power. Do I have any other variable that has x to the first power? And I'm going to say no, so I would just have minus x. And then I have my constant. So I'm going to look at my constant. I have a negative 3 and a positive 8. And we're going to say, oh, okay, well, negative 3 plus 8 is positive 5. So now I'm going to look at my answer and make sure that I have this written in standard form. Do I have the highest exponent at the beginning? Yes. See, I go in descending order. X to the third, x to the second, x to the first, x to the 0. So my leading coefficient would be 6. That's the number that is in front of our biggest exponent. And our degree would be 3. The highest exponent that you see is to the third degree. Okay, we're going to look at the second question. This one's a little different because there is a minus sign in front of the second parenthesis. What that means, guys, remember, that means negative 1. So I have to multiply, I have to distribute a negative 1 to everything behind that minus sign before I can combine like terms. So I'm going to rewrite my first parentheses. It's 7x to the fourth minus x squared minus 4x plus 2. Now I'm going to distribute that negative 1. So negative 1 times 3x to the fourth gives me negative 3x to the fourth. Negative 1 times negative 4x squared gives me positive 4x squared. And then negative 1 times positive 3x gives me negative 3x. So now that we have that negative 1 distributed, we can go through and combine like terms. So the highest exponent I see is 4. So I have a 7x to the fourth and a negative 3x to the fourth. So when I combine that, 7x to the fourth minus 3x to the fourth gives me 4x to the fourth. Then I'm going to say, okay, do I have an x to the third? No, no x to the third. So now I go to the next exponent, x squared. So I have a negative x squared and a positive 4x squared. So as we go through that, negative 1 plus 4 is going to give me positive 3x squared. Then I have a negative x to the fourth and a negative 4x and a negative 3x. Well, negative 4 minus 3 is negative 7x. And then I have my little constant left of 2. And that's going to bring up the rear. So when I simplify, I combine like terms and everything, I get 4x to the fourth plus 3x squared minus 7x plus 2. So my leading coefficient would be 4, and the degree of this polynomial would also be 4, because we write our exponents in descending order from highest to lowest. Now, the next thing we're going to talk about is something that you guys have seen since you were probably in middle school, Algebra 1 kind of thing, is we're going to do operations with polynomials where we multiply. All that is, guys, is remember, when you are multiplying variables that have the same base, you have to add the exponents. So in this first example, number 1, all we're doing is distributing negative 4x to everything in this parenthesis. So I'm going to say negative 4x times 3x squared. Well, negative 4 times 3 is negative 12. X to the first times x to the second gives me x to the third. So now I have negative 4x times positive 5x. Well, negative 4 times 5 is negative 20, and x times x gives me x squared. Then I have negative 4x times negative 1. Negative 4 times negative 1 is positive 4, and my x comes along. I cannot combine anything anymore because I have x squared, x cubed, and x. I don't have any like terms. But I can say that negative 12 is my leading coefficient, and the degree of this polynomial is 3, because when we have it written in standard form, it's highest exponent at the front. All right, secondly, we're going to look here, and this is just a classic binomial times a binomial. We're going to FOIL. I'm going to take the first term and multiply it by the first term. So negative 7y times 5 gives me negative 35y. First term times the outer. So negative 7y times negative 9y. So negative 7 times negative 9 is positive 63. And y times y gives me y squared. Now I'm going to take the inside times the inside. Positive 3 times positive 5 is 15. And then the inside times the outer. 3 times negative 9y is negative 27y. Now, we need to write our answers in standard form, and we need to make sure we combine anything that has like terms. So, the biggest exponent I see is y squared. Do I have any other y squareds? No, so I'm just going to rewrite 63y squared. Then the next exponent would be y to the first. So I have a negative 35y and a negative 27y. Well, negative 35 minus 27 gives me negative 62y. And then I have my constant, my little positive 15, and I have plus 15. Nothing else to combine because nothing has like terms, but I can say that the degree of this polynomial is 2. It's the biggest exponent when we put it in standard form, and the leading coefficient is 63. All right, this last problem is the exact same thing. All we're doing is distributing a whole bunch of times, but you guys got to be really careful when you get to stuff like this. Just take your time. I'm going to take this 3y squared, and I'm going to multiply it to every term in the second parenthesis. So 3 times 4 is 12. Y squared times y to the third. You add exponents, it's y to the fifth. 3y squared times negative 5y squared. Well, 3 times negative 5 is negative 15. Y squared and y squared gives me y to the fourth. Then I have 3y squared times 9y. 3 times 9 is 27. Y squared times y is y to the third. Now we do the exact same thing, but with 6. So I'm going to say 6 to 4y cubed gives me positive 24y cubed. 6 to negative 5y squared is negative 30y squared. And then 6 to positive 9y, well, 6 times 9 is 54, and then I have y. And now we're going to make sure that we are written in standard form and that we combine like terms. So the highest exponent I see is y to the fifth. So I have 12y to the fifth. I don't have any other y to the fifth, so I just write that down. The next highest exponent I see is to the fourth, so I have negative 15y to the fourth. No other y to the fourth, so I have negative 15y to the fourth. The next exponent I see is y to the third, so I have a y cubed here, and I have a y cubed here. So 27 plus 24. Well, 27 plus 24 is 51 y cubed. Then I have y squared. Nothing else has a y squared, so I have minus 30y squared. And then plain old y, so plus 54y. Again, we are written in standard form because our exponents go from biggest to smallest. My degree of this polynomial would be to the fifth degree, or 5. And my leading coefficient would be 12, the number in front of the exponent, or the variable that has the highest exponent. When we talk about special products, it's really easy to get lost in this sort of thing and to get yourself confused. But you can find little shortcuts that if you learn them, it kind of makes your algebra and your math a little easier. First thing we're going to talk about is the sum and difference formula. If you look at this example here, the terms in each parenthesis, the first parenthesis and the second parenthesis, are the same. The only thing that's different is the sign in between. So when you multiply two binomials that have the same terms in them, but the signs are different, in essence what's going to happen is you're just going to square the first term, square the second term, and put a minus sign in the middle of it. If you don't see that right off the bat, that's okay, but you guys, the more you practice this, you'll get into that. But if I multiply this out, x times x, x squared, x times negative 4 is minus 4x, 4 times x is plus 4x, and 4 times negative 4 is negative 16. So if you notice, you're left with x squared, my negative 4x, my positive 4x cancel out, minus 16. So when you have two terms that are exactly the same in each binomial, but the signs are different, all you have to do is square the first term, square the second term, and put a minus sign in the middle. In a case where you have the same binomial squared, when I have x plus 3 quantity squared, that means I have x plus 3 2 times. So when you FOIL this out, x times x is x squared, x times 3x is 3x, 3 times x is 3x, 3 times 3 is 9. What happens here is you just end up doubling that middle term. So it's x squared plus 6x plus 9. Again, you don't have to, if you don't recognize that, that's okay. You can still FOIL it out, but sometimes it's just helpful and a little quicker if you do special patterns. Again, this is another special product. What this is in a sense saying is 3x minus 2 times 3x minus 2. It's 3x minus 2 quantity squared. So again, you're going to square the first term, double the middle, square the end. But watch, 3 times 3 is 9, so 9x squared, minus 6x, minus 6x, plus 4. So when I combine, I have 9x squared minus 12x plus 4. And again, if you don't see that right off the bat, it's okay. You can just FOIL it out. More special patterns down here. This is really x plus 2 times x plus 2 times x plus 2. So if I FOIL this out, I'm going to rewrite x plus 2 out here, and I'm going to FOIL. X times x is x squared plus 2x plus 2x plus 4. This becomes 4x. Then I'm going to FOIL again. So x times x squared is x cubed. X times 4x is 4x squared. X times 4 is 4x. 2 times x is 2x squared. 2 times 4x is 8x. And 2 times 4 is 8. So when we combine, we have, excuse me, x cubed plus 6x squared plus 12x plus 8. And if you follow the pattern of what this will look like, if you knew the pattern, it's right here. But again, guys, don't get yourself bogged down on that. If you don't know the pattern, that is okay. So, sum and difference of same terms. Find the product. What you're going to end up doing is square this, put a minus sign in the middle. So it's going to be 25x squared minus 81. But then let's write it out, because again, if you don't recognize that pattern, if that doesn't make sense to you, you can still find the answer by FOILing. 5x times 5x is 25x squared. 5x times negative 9 is negative 45x. 9 times 5x is 45x. 9 times negative 9 is 81. If you notice here, you have 25x squared, negative 45, positive 45 cancel out, minus 81, which is what we said up here at the beginning. So if you guys don't recognize the special patterns, that is okay. I wanted to go through some of your homework from last night, but since I don't have you face-to-face, I don't know your exact questions, I'll wait and do this tomorrow. It is right here. It's going to be P3. You guys are going to do numbers 5 all the way to 51. Odds only. So it's going to be 9. You're going to do 11, 13, 15. This whole section here. 25, 27, 29, 38, and here. I know some of you are like, oh my gosh, that's so much. It's really not that much. We need to practice when we're adding and subtracting here. You got to practice. Remember, if there's a negative sign, you got to distribute the negative to the second parenthesis. If you don't like writing T's, because sometimes T's turn into looking like plus signs and stuff, that's fine. Go ahead and just write X. You can change it to any letter you want to. And then when you multiply, make sure when you multiply over here in this section, and we're talking about, there's some multiplying here too. When we're talking about the bases being the same, you have to add exponents. So just make sure you guys are on top of that. And then any questions you have, I promise we'll go over tomorrow in class. I'm going to dedicate to just answering questions and stuff. So I hope you guys have a wonderful afternoon. Happy Monday. I miss seeing you guys, but we will chat tomorrow. Okay. Your homework tonight